Um, okay, so sorry, YouTube Nation and Pickup, we're going to do integrals. We're looking at this sheet right here, our various calculus notes. We can see some integrals over there on the right-hand side. And we got 5 minutes. Okay, so I chose u to be 4x to the 5th plus 3. You said, why did I choose that? This requires some foresight, okay? First of all, I said u is going to be that because du is basically that, right? So another thing I'm looking at is that I would then have 1 over u, and the integral of 1 over u is natural log of u. We don't just say ln, we actually say the word natural log, okay? Okay, no. Oh, idiots. All right. Okay. Yeah. Okay. Now, I have used the term freedom fries before. Darn right I have. Okay. So, I got the integral of what? Oh. Okay. YouTube Nation is just a lot of laughing going on. All right. We done? Done. Everybody got it? All right. Here's another one. That was the answer. Okay. Let's try another one. Integral of 36x squared e to the 4x to the 3rd plus 3 dx. Again, problems that look challenging, but really they're not that bad. We just make the correct substitution. That's 36 e or x squared e to the 4x to the 3rd plus 3 dx. Yes, u is equal to 4x to the 3rd plus 3. Therefore, du is 12x squared dx. Do I have a 12x squared dx? 3 du is equal to 36x squared dx. So I have 3 times the integral of what? E to the u du. What's the antiderivative of e to the u? E to the u times 3. 3e to the 4x squared plus 3 plus constant. Oh, shoot, sorry. Yep, 4x to the 3rd, that's what u is. All right. Okay, problem number 3. 80x to the 3rd times 3 to the 5x to the 4th minus 2 dx. Yep, the minus 2 is up top in the exponent. So what'd you say u is? Yes, u is 5x to the 4th minus 2. So du is times it by 4. I have my substitution. 4. 3 to the... Do you remember what the antiderivative of 3 to the u is? Good try, close. We'll check it when you get back. Okay, with your various calculus notes, do you know the antiderivative of 3 to the u? right here, we've got, it's the antiderivative of b to the u, or a base, like 3, would be 3 to the u over the natural log of 3. Okay? I thought you said times. I thought you were referring to this one, either this one or this one right here. Okay, you said that one. You were wrong. She was right. Okay, so we'll say this is equal to 4 times 3 to the 5x to the 4th minus 2 over the natural log of 3 plus a constant. Yep. You cannot take the 4 times the 3 to get 12. Totally illegal. You're... What? Yep, you could put 4 times 3 on top. That'd be fine. We'll leave that up to you. All right, number 4, 2 over x times negative 1 plus natural log of 4x dx. Okay, so Bo says that u is equal to negative 1 plus the natural log of 4x. You're correct. Sure. And so du is equal to, derivative of negative 1 is 0. Derivative of natural log of 4x. So the derivative of the inside is 4 over, derivative of the outside is 1 over u. And what is u? 4x. So you still just get 1 over x dx. You have a 1 over x dx. You have a 2. So 2 du is equal to 2 over x dx. So now I can set it up. 1 over u. What's the integral of 1 over u? Natural log of u, so we have 2 times the natural log of, and u is negative 1 plus the natural log of 4x. Plus my constant. See that? You like it? Alright, let's try the next one. Alright. Number 5, the integral of 20x to the third divided by the square root of 25 minus 25x to the 8th dx. Good guess. U is 25 minus 25x to the 8th. Unfortunately, that doesn't... Just think about if u was 25 minus 25x to the 8th, du would be negative 200x to the 7th. Yeah, but you'd have that top piece up there. You got that x to the third. Okay. Kimball's making up mathematics now. This is going to have form very similar to this. The integral of 1 over the square root of 1 minus u squared du is equal to sine inverse of u plus c. Remember that? Remember when we took the derivative of arc sine and we got 1 over the square root of 1 minus x squared? Okay. Yep. Yep. So now we're going to take antiderivatives of those. What? Yes. Watch me work my magic. Thank you. Okay, so is 25 a perfect square? Can I remove that then? It becomes a 5, right? So this is the same thing as 1/5 times the integral of 20x to the third over the square root of 1 minus x to the 8th, correct? Now I'm not going to write x to the 8th. I'm going to write something else. Because when I look at my form right here, it says 1, look, 1 minus, do I have the 1? But I have the minus. I need something squared. What is it that I squared? X to the 4th. So I have x to the 4th quantity squared, dx. Now, 20 times 1/5 gives me 4x to the 3rd over the root of 1 minus x to the 4th squared dx. 1/5 times 20 gave me 4. What is u? Just look at right here, folks. U is whatever sits in that spot. X to the 4th is what u is. Therefore, du is do I have a 4x to the 3rd dx? I do. So therefore, I have the integral of 1 over 1 minus u squared du. What is the antiderivative of 1 over the square root of 1 minus u squared du? Arc sine of u. What's u? You raise a very good question. Some people will never be able to do these by themselves. Let's try another one. Now look at this one, number 6. What form is number 6 going to be like? Arctan. Arctan. So it helps to identify the form ahead of time. And the form is this. 1 over 1 plus u squared du is equal to arctan of u plus a constant. So you tell me, what should I do first here? Factor out factor out a 1/9. And when you do that, on top you have 10x to the 4th. And on the bottom, 1 plus 4 over 9 x to the 10th. Now you can see that I have a 1 and I have a plus, but I need a perfect square. Is 4/9 x to the 10th a perfect square? Yes. What do I multiply to get? What do I multiply by itself to get 4/9 x to the 10th? 2/3 x to the 5th. So I'm going to write this as follows. 1 over 9 times the integral of 10x to the 4th over 1 plus 2/3 x to the 5th, that quantity squared dx. Yes. because when you multiply bases, you add the exponents. All right, what is u? So du is, yep, I don't have a 10 over 3, but I do have a 10, so I'm going to multiply by 3. I got 3 du is equal to 10x to the 4 dx. So I put that 3 out front, right? It's 3 times a 9. So 1/3 integral of, I know that integral, arctan. Yeah. Okay, so here's what I would like you guys to do. I have 4 problems written right here. And then on the board, I have 3 more. So these 4 and then those 3, that's your assignment. So far for your test, you need to apply L'Hopital's rule. You need to do integration by parts. And you have to do inverse trig and logarithmic integrals. Yeah, I'm pretty sure. What? Yes, you could tell second hour all about the content of their homework.